Problem 6 is as follows. We have a trapezoid ABCD has AB parallel to CD, BC equals CD equals 43, and AD is perpendicular to BD. So let's try to draw a diagram. We're given that AB is here, then CD is here, and we're given that that's 43, and that's also equal to BC. So we're maybe looking at this, where these are equal, right? 43 and 43. Then AD is also perpendicular to BD, so it looks like we're going to need to redraw that, right? Okay. So again, don't be afraid to start drawing diagrams, but of course, you're probably going to have to redraw it if the diagram's pretty complex like this one. Okay, so it looks like instead, we're going to draw here. Let's start with D, right? And we're given that we have a right triangle ABD. And we also know that BC equals CD. So we have some isosceles triangle, right? BCD, like this. And they're both equal to 43. Let O be the intersections of diagonals BAC and BD. And let P be the midpoint of BD. Okay? We're also given that OP is equal to 11. And the length of AD can be written as m root n. Okay. So now we need to figure out what AD squared is. And remember that P is the midpoint here. So it looks like we have some missing lines, right? In particular, we know that BC equals CD. So a very attractive line to draw right now is CP. We have this perpendicular bisector of BD because P is the midpoint, right? So when we draw this, we actually get a lot of new information, right? Let's take a look. So first of all, we have these parallel lines, and we also have these parallel lines. Let's think about what we can do with parallel lines. One thing we can do is, of course, figure out, well, given these, right, we can figure out the ratios based on these parallel lines. In particular, if we can find some of these lengths, the rest of the lengths are actually really easy to find. So let's list out some possible triangles that we can use. For example, here, if we have AB is parallel to CD, that means that triangle ABO is similar to triangle, because, for example, these two angles have to be equal. ABO is similar to CDO, right? And so we can write some nice ratios. In this case, for example, we can figure out that OD to OB is equal to OC to OA, right? But notice OC to OA, well, that we can use a second pair of these similar triangles, and these are right triangles. ADO is similar to CPO, right? So you can see that from that we get OC over OA again is equal to OP over OD, and it's also equal to, let's see, CP over AD, right? So we notice that all of these ratios are the same, in particular OD over OB. So now's a good time to assign variables now. Let's say OD is x. This makes this x plus 11. So then we get that OD over OB, which is x over x plus 22, is also equal to OP over OD, which is 11 over x. So now we actually just have an equation in x that we can easily solve. In particular, we cross multiply to get x squared equals 11x plus 11 times 22. And then we get this, which is solvable by using the quadratic formula. Let's do it. X equals 11 plus or minus square root of 11 squared plus 4 times 11 times 22, all over 2, which simplifies to 11 plus or minus squared. Well, we can take out an 11. That becomes 11 plus 4 times 22. Notice that that's, or we can take out 11 squared, right? We get 1 plus 8, which is 9. So we actually get that x must be, right, some integer. We can see that 11 squared times 9 is just the square root of 33. So you get that x must equal, well, 33 over 2, right? The other root is negative, which we don't care about. So we get that x is equal to 11 plus 33 over 2, or 22. So let's fill that out, right? That just means that all we need to do is find the remaining lengths. So in this case, right, we know what this is, so we can figure out everything else, right? Notice that we're also given BC equals 43. So for example, in triangle BPC, we have a right triangle with hypotenuse 43 and leg x plus 11, which is 33. So really, and now is a good time to draw a new diagram. Here's what it looks like, right? We have length of 33 and another length of 33. We have this, and we're given that this is 43. And P here, or O here is here, and this is 11, and this is 22. And then let's finish this diagram. Looks something like this, with this being a right angle and this being parallel. Okay. So now, in this case, right, we can quickly solve for the remaining lengths here, right? Let's first solve for CP, and then notice that that's just half of AD by right triangles ADO and CPO. So we get that CP equals square root of 43 squared minus 33 squared, which equals square root of something like 76 times 10. That's 4 times 19. So we get that this is 2 times the square root of 19 times 10, or 190. It follows from similar triangles, right, this one and this one. Since they're in the ratio 2 to 1, that AD must equal double that, or 4 root 190. So we can see that if, this was off screen, 4 root 190 is here. So then if it can be written as m root n, right, 4 and 190, then m plus n must be 194. Final answer.